Every bridge you drive across, every vehicle on the road, every skyscraper that dominates a city skyline, and even the machinery that powers modern industries have one thing in common. They all depend on welding. Yet most people never stop to think about the process holding these massive structures together. A single failed weld can lead to equipment breakdowns, costly repairs, or even catastrophic structural failures. On the other hand, a properly executed weld can withstand decades of stress, vibration, extreme temperatures, and heavy loads. What makes welding so remarkable is its ability to permanently join separate pieces of metal into a single solid structure. It's one of the most important fabrication processes ever developed and remains the backbone of industries ranging from automotive manufacturing and aerospace engineering to shipbuilding and renewable energy. But welding today is far more advanced than it was a few decades ago. Modern welding technologies now include robotic welding systems, laser welding, AI-assisted quality control, friction stir welding, and even welding processes performed underwater and in outer space. In this guide, you'll discover what welding is, how it works, its major applications, the different types of welding used today, and the advantages and disadvantages that every welder should know. Let's get started. What is welding? Welding is a fabrication process that permanently joins two or more materials by applying heat, pressure, or both. As the materials cool, they fuse together to form a strong and durable connection known as a welded joint or weldment. The process is most commonly used on metals and thermoplastics, although specialized methods can also be applied to wood and composite materials. At its core, welding works by creating a bond between materials at the molecular level. Unlike mechanical fasteners, such as bolts or rivets, a welded joint essentially becomes one continuous piece of material. In many welding processes, an additional material called a filler metal is introduced. This filler melts and combines with the base metals, helping create a stronger and more reliable joint. To protect the molten weld pool from contamination, shielding gases, flux coatings, or other protective methods are often used. Without proper shielding, oxygen and other atmospheric elements can weaken the weld and cause defects. Today, welding is considered one of the most essential manufacturing and fabrication technologies in the world.
Diagram of welding. A typical welding setup consists of base metal, or workpiece, welding arc or heat source, filler metal, weld pool, shielding gas or flux, and finished weld bead. The heat source melts both the base metal and filler material, creating a molten pool that solidifies into a strong welded joint. Why welding is important? It's difficult to imagine modern life without welding. Almost every major industry depends on it because welded joints offer exceptional strength, durability, and reliability. Without welding, many of the structures and products we rely on daily simply could not be manufactured efficiently. Welding plays a vital role in transportation, construction, energy production, manufacturing, aerospace, defense, and infrastructure development. In many applications, welding creates joints that are stronger than the surrounding base metal itself. Applications of welding. One of the reasons welding remains so important is its incredible versatility. Let's look at some of the most common applications. 1. Construction industry. The construction industry relies heavily on welding for assembling structural steel frameworks. Welding is used in high-rise buildings, bridges, stadiums, towers, and industrial plants. Large steel structures require thousands of welds to maintain strength and stability. Without welding, modern skyscrapers would be nearly impossible to build economically. 2. Automotive industry. Automobile manufacturers use welding extensively during vehicle production. Welding is used for chassis assembly, body panels, exhaust systems, suspension components, and battery enclosures for electric vehicles. Modern vehicles may contain thousands of individual weld points. Robotic welding systems now perform much of this work with incredible precision. 3. Aerospace industry. Aircraft components demand extremely high-quality welds because human lives depend on them. Welding is used to fabricate aircraft frames, jet engine components, fuel tanks, and landing gear assemblies. Processes such as TIG welding, laser welding, and electron beam welding are common in aerospace manufacturing. 4. Shipbuilding industry. Ships operate under constant stress from waves, corrosion, and heavy loads. Welding is essential for hull construction, deck structures, propulsion systems, and offshore platforms. The strength of these welded joints directly impacts vessel safety.
5. Oil and gas industry. The oil and gas sector depends heavily on welding. Applications include pipelines, offshore drilling platforms, pressure vessels, storage tanks, refinery equipment. Many of these welds must withstand high pressure and harsh environments. 6. Manufacturing industry. Factories use welding to assemble countless products. Examples include industrial machinery, agricultural equipment, appliances, metal furniture, and production equipment. Welding allows manufacturers to create durable products efficiently. 7. Repair and maintenance. Welding is not limited to manufacturing. It is also used to repair cracked machinery, broken frames, damaged pipes, and worn components. Repair welding often saves businesses thousands of dollars compared to replacing equipment. 8. Art and sculpture. Many artists use welding as a creative tool. Metal sculptures, decorative pieces, furniture, and architectural artwork often rely on welding techniques to bring designs to life. How does welding work? Although there are many welding methods, most follow the same basic principle. Step 1. Preparation. Before welding begins, the surfaces must be cleaned. This involves removing rust, oil, dirt, paint, and contaminants. Proper preparation ensures better fusion and reduces defects. Step 2. Heat generation. A heat source is applied to the joint. Depending on the welding process, heat may come from electric arc, gas flame, laser beam, electron beam, friction, or resistance heating. The heat melts the base metal and, in many cases, the filler material. Step 3. Formation of the weld pool. As the materials melt, they form a molten puddle known as the weld pool. The welder controls the shape, size, and movement of this pool throughout the welding process. The quality of the weld often depends on how well the weld pool is managed. Step 4. Shielding. Molten metal reacts quickly with oxygen and nitrogen. To prevent contamination, shielding is used through flux coatings, shielding gases, flux-cored wires, and submerged flux systems. This protection helps produce stronger welds. Step 5. Solidification. As the weld cools, the molten metal solidifies. This creates a permanent bond between the workpieces. The finished weld bead becomes part of the structure itself. Main types of welding. Several welding methods are used throughout industry. 1. Shielded metal arc welding, SMAW, stick welding. Stick welding uses a flux-coated electrode to create an electric arc. Common uses are construction, maintenance, pipeline work, structural steel. Benefits are portable, affordable, and excellent for outdoor work.
2. Gas metal arc welding, MIG welding. MIG welding uses a continuously fed wire electrode and shielding gas. Common uses: automotive manufacturing, fabrication shops, home workshops. Benefits: fast, easy to learn, high productivity. 3. Gas tungsten arc welding, GTAW, TIG welding. TIG welding uses a tungsten electrode and separate filler rod. Common uses: aerospace, stainless steel fabrication, precision welding. Benefits: superior weld appearance, high precision, excellent quality. 4. Flux-Cored arc welding, FCAW. FCAW uses a tubular wire filled with flux. Common uses: construction, heavy equipment manufacturing. Benefits: high deposition rates, suitable for outdoor use. 5. Plasma arc welding, PAW. This process uses a focused plasma arc for precise welding. Common uses: aerospace, medical equipment. 6. Gas welding. Gas welding uses oxygen and fuel gas to create heat. Common uses: maintenance, repair work, pipe welding. 7. Submerged arc welding, SAW. The arc is hidden beneath a layer of granular flux. Common uses: pressure vessels, large steel structures, shipbuilding. 8. Laser beam welding, LBW. Laser welding uses concentrated light energy. Common uses: electronics, automotive production, EV battery manufacturing. 9. Electron beam welding, EBW. Uses high-speed electrons in a vacuum environment. Common uses: aerospace, nuclear industry. 10. Friction stir welding, FSW. A solid-state welding process that joins materials without melting them. Common uses: aircraft structures, electric vehicle battery enclosures, railway manufacturing. Modern welding advancements in 2026. The welding industry has changed dramatically in recent years. Robotic welding. Modern factories now use robotic welding cells capable of operating 24/7 with incredible consistency. These systems improve speed, precision, productivity, safety. Artificial intelligence welding. AI-powered welding systems can monitor arc stability, heat input, weld penetration, defect formation. The system automatically adjusts parameters in real time. Smart welding helmets. Today's helmets feature auto-darkening lenses, grind mode, Bluetooth connectivity, digital controls, enhanced optical clarity. These innovations improve both safety and productivity. Laser hybrid welding. Manufacturers are increasingly combining laser and arc welding technologies. This provides faster welding speeds, deeper penetration, and reduced distortion. Electric vehicle welding technology. The rapid growth of EV production has accelerated the adoption of laser welding, friction stir welding, and automated battery welding systems. These technologies help create lighter and stronger battery structures. Advantages of welding. Welding offers numerous benefits across industries. Strong and durable joints. A properly executed weld can be as strong or stronger than the surrounding material. Permanent connection. Welded joints provide long-term reliability. Cost-effective. Compared to many fastening methods, welding often reduces material and labor costs. Versatility. Welding can join thin materials, thick materials, similar metals, dissimilar metals. Attractive appearance. Well-executed welds can provide clean and professional-looking joints. Automation-friendly. Modern welding systems can be fully automated for mass production. Flexible applications. Welding can be performed in various positions and environments, including underwater and in space. Disadvantages of welding. Despite its benefits, welding also has limitations. Safety hazards. Welding involves extreme heat, UV radiation, sparks, fumes, electrical hazards. Proper protective equipment is essential. Requires skilled operators. High-quality welding requires training, experience, and attention to detail. Permanent joints. Unlike bolts or screws, welded joints are difficult to disassemble. Distortion risk. Uneven heating and cooling can cause warping. Equipment costs. Advanced welding equipment can be expensive. Inspection requirements. Critical welds often require extensive testing and inspection.
Conclusion. Welding is one of the most important fabrication processes in the modern world. It enables manufacturers, builders, engineers, and fabricators to create strong, reliable, and permanent connections that form the backbone of our infrastructure and industries. From bridges and skyscrapers to automobiles, aircraft, pipelines, and electric vehicles, welding plays a crucial role in shaping the world around us. As technology continues to evolve, innovations such as robotic welding, AI-powered quality control, laser welding, and friction stir welding are making the process faster, safer, and more precise than ever before. Whether you're a beginner learning the basics or a professional welder looking to expand your knowledge, understanding what welding is and how it works provides the foundation for mastering one of the most valuable skills in modern manufacturing.